Hello students, in this assignment, we have to help Mr. John in creating a data-driven process for selecting a location for a new store. John is a sales analytics manager at STA, which is Star Retailers. As a retailer, own several small grocery stores across the country. And each year they expand their presence by opening some more stores. Now, John's team invests a large amount of time and efforts in selecting the site for new grocery stores. Now, John wants to make use of data skills he has recently acquired to make this process data driven. He thinks of using past data to create a linear regression model to predict new store revenue, to predict revenue generated by the new store. Now let's look at the past data that is available to John and his team. After that, we'll be creating a model to predict the revenue of stores using this past data. So this is the data that we have. This is our dependent variable, which is the revenue. We want to estimate this value for our new stores. We are using these independent variables. So by using this, we want to predict this dependent variable out here, which is the revenue. We have around 5 independent variables, 1, 2, 3, 4, and 5. First one is the type of location. Next variable is the type of city. Then we have the marketing and sales investment information. We have the dollar value of such investment in this column. Then we have estimated population in the vicinity of our store. And then we have a column of average household income in the vicinity of that store. So this is the past data of our stores. We have data of around 1,000 such stores. Yeah. So going from top to bottom. Yeah, we have here data for 1,000, around 1,000 such stores is available. Now let's look at this independent variable. The first one is the type of location of the store. Yeah, so this is the one, the very first one. Now to look at what all values in this variable takes, we can apply filters on our data, just like we saw in our all the previous assignments during our certification. Selecting this row and going to the data tab, applying filters. Yeah. So once you have applied the filter, you will be able to see this drop down button, and inside this drop down menu, you will see what all values our variable are taking. And so on. And in some of these, you saw limited number of variables. Some of them you saw numerous. Yeah. So we are going to learn about it. I'll be discussing about it. So first, let's look at the locations. Yeah. So if I open this up, yeah, or expand this, you can see that there are two values, that is commercial and residential. And this signifies that whether we are opening our store in a commercial space or a residential space. Then we have city type. City type means whether the city in which we have opened the store is a metro city or a non-metro city. So you can see there are two values in the column, metro and non-metro. These two are the categorical variables, the very first two, types of location and city types. So that's why you don't see lots of options. These are non-numerical, so categories. Yeah. So here there are two categories, commercial, residential. Here there are two categories, metro and non-metro. So categorical variables do take textual data only. The next three variables are continuous numerical variables, which is marketing, sales, investment, estimated population in the vicinity, average household income. So the very first one, that is investment in sales and marketing. This is the amount of money we invested in sales and marketing efforts, such as doing paid promotion, launching offers, etc. for our stores. As you can see, this is a continuous variable. This is why if we click on the filter icon, we can see multiple values, numerous values. Yeah. Then the next column is estimated population in the vicinity of our stores. Then in the next one, we have household income near our store. Now that at last, we have the dependent variable, that is our outcome that we are looking for, that is the revenue. Now using our linear regression model, we want to use this independent variable. So this one, independent variable, all these to predict the revenue. Yeah, so 1, 2, 3, 4, and 5 to predict the dependent variable, that is the revenue. That's when we'll be utilizing the linear regression model. We want to use it to make a prediction. After building such a model, we will be able to identify revenue of our new store from these independent variables. So in a way, before investing a property to open a new shop, a new store, we'll be able to identify its revenue or predict its revenue. And we will also be able to identify whether the store revenue will be higher than our expected values or not. If the revenue we are getting are acceptable, then we can go ahead and open that store. So this is all our data. Make it bigger. So to summarize, we have three continuous so we have three continuous independent variables, 1, 2, and 3. And we have two categorical independent variables, 1 and 2, which takes textual data only. And we have one dependent variable, that is your revenue. Now we will process our data to make it ready for the linear regression model. Now, as you can see that we have two categorical variables. And to run a linear regression model, we only need numeric variables. So in this part, we will convert these two categorical variables into numerical variables. Now let's create another copy of this data set. I'll name it as pre-process. So you see what I'm doing, hovering my mouse to this data sheet, right click. I will select move or copy. Here I will select create a copy. Again, by default, data set is selected, but I will reselect just to show you. So we are ready to create a new sheet that is a copy of the data sheet. Now you can see a new copy of the data is being created with this parenthesis 2. I'll drag, take it to the extreme right, and rename is to pre-process. Now, first of all, we don't need this very first, that is serial number of variables. So I can just go ahead and delete this column. Now we need to convert the first two categorical variables. And if you see these two categorical variables in the first two columns, which is the type of location, variables, and a city name. So these two have just two categories each, 1, 2, 1, 2. So we can convert these categorical variables into numerical values by adding just one additional value that will take a value of 0 or 1. Yeah. So for example, I will explain that as we go. Yeah, let's move forward. So we can assign 0 for commercial and 1 for residential. So if a cell contains 0, that means that the type of location is your commercial, and if the cell contains 1, it means that a type of location is residential. So we can just use one single column to replace this categorical variable by a numerical variable. So now let's go ahead and insert a new column to do this. So I'm going here, right click on this top tab C and say insert. Here we will write our column name as let's see type of location underscore residential. I'll explain, or say location underscore residential. I just do it slowly so that you can catch up with this. So again, this name location underscore residential, this means that if the location is residential, then this variable will have a value of 1. If not, meaning it is a commercial, it will have a value of 0. Now to create such a column, we can use if statement. Yeah, that is a conditional statement. So let's go ahead and do that. So yeah, equals to if. I say I want this cell A4 equals to residential. Yeah, so if this equals to residential, then I want the output to be 1 or I want the output to be 0. Now let me click enter. Now to expand this formula all the way to the entire table, I'll just go here on the right hand bottom corner and double click over here. So you can see in the first row, the location is commercial and the output is 0. And in the next one, the location is residential and the output is 1. And I can see as I can go below, for all the residential, the output is 1. And for the commercial, the output is 0. So this formula is working. So here we have successfully converted this categorical variable into a numeric variable. Now let's move to the second categorical variable in in this type. Yeah, so that is the city type. So I'll go ahead and add another column, say insert. We'll name this city type underscore metro. Again, this means that this variable take a value of 1 when the city type is metro, or it will take a value of 0 if it is a non-metro. So again, we'll use the if statement. So we'll write the F cell. We'll write. Yeah, let's do this. Let's continue with our formula equals to if bracket cell B4 equals to metro. Yeah. So if this condition is true, I want the output to be 1 or else I want the output to be 0. Now I will expand this formula all the way down to all the 1000 data sets. Now let me recheck. So for the very first here in cell B4, my city type is non-metro, the output is 0. Next one, my city type is metro and output is 1. And the same is the case for next 4 and here also. And for the next 3, my city type is non-metro and 0. So looks like my formula is working. So here we have successfully converted our two categorical variables into numerical variables. Now we can use this information for building a regression model. So now let's move forward to create a regression model. Now let's go ahead and use these newly converted numerical variables along with other variables to create a linear regression model in Excel. But before doing that, we need to activate the data analysis add-in. And in order for you to do that, let's do this. I'm going to the Files tab over here, and all the way to the bottom, I can see this option. Please click on that. Then a window like this pops up. Here, I'll go to this Add-ins tab, and here I will select Analysis Toolpack. And I will say, yeah, Excel add-ins, say go. Here I'll see multiple options. For you, everything might be unchecked. So go ahead and check this and say OK. Once you do that, now you come to this Data tab, and here you can see this Data Analysis tab has been activated in this analysis. Yeah, please go ahead and do that. Once this appears, I want you to click on this Data Analysis tab. Here, yeah, this is a type of window that will pop up. I want you, or let's go ahead and click on this regression and click OK. And a window like this will pop up. Here you can quickly browse and see, scroll and see. Very first, it is asking for your Y variable, that is your output or the dependent variable. And here it is asking for the input X range, that is your all your X values or your input variables or your independent variables. On top of it, there are some more options which we will be discussing shortly. So for the very first, let's go ahead and select the Y, that is your output or the dependent variable, a variable that is dependent on several inputs. So the very first, so in this case, it's your revenue. So I'll click on this part arrow over here, and a window like this will pop up. I will select this revenue as well. And now I will click Control Shift all the way down. It will go to the last available data point. Once that's done, I will go here and I will go to the my X range variable, which are my input variables. And these are the 5 numerical variables we will be using. So I'll go all the way up and I will use all of these starting from location underscore residential to average household income. So I'm selecting all of these, and now I will again select Control Shift down arrow. It will yeah, take all the data points until the last available data point. Now I'll go back, and here if you have noticed, when I was doing the selection, I have also selected these titles. So in Excel, these titles are also here, also called as your labels. So since I've selected those, I will check this box. Other all options look good to me. So I'll click OK. And now in a new sheet, I will see this output summary. Please go ahead and complete this part. Once that's done, here is the result of our linear regression that we'll be seeing. So whatever you get in the result of linear regression, the first thing you have to check is your significant F value over here. And again, I will repeat, this is each and every time this is the output of linear regression model you'll be getting. So any linear regression you run using Excel or any other software, this is the summary file you will be getting. And the very first, very most important number you will be checking is your significant F value. So I will highlight this using a different color, say yellow. And here I'm seeing a number, say 2.8 into e raised to minus 174, meaning it's a 2.8 into 1 divided by 10 raised to minus 174. So this means that it is extremely small value and it is almost equal to zero, very near equal to zero, and this is almost equal to zero. So in other words, this is 1 multiplied by 1 divided by 10 raised to minus 174. Yeah, so it's extremely small value equivalent to zero. And here is something. So the significant F value that you are looking for must be less than or equal to 0.01 as per the statistical theory. So this is the number you are looking for. Yeah. So if so you see it's 0.01 or less is what you are looking for. Sorry, this is opposite. And this is way smaller than that. Yeah. So this tells me that I have a very high confidence in my relationship with relationships of all the input variables on the response variable, that is output variable. So in other words, you can see that the independent variables that you are using have some kind of strong relationship with the dependent variable or the target variable. So in this case, it's revenue. So I can strongly say, confidently say, with high level of confidence, I can say that the independent variable has a strong relationship with all the input variables or the dependent variables. So that is the very first one. So you can see, yeah, like F value is extremely smaller. Now, once that is done, so this part is done, so we can move ahead because yeah, we have strong confidence. It doesn't, it doesn't hurt. And again, there is a very high level of confidence. Yeah. Now the second part, once that is done, when this is confirmed, now the next part or the next number you are looking is for the accuracy of our model. Yeah. So I just type in over here, say check for accuracy. Check for accuracy of our model. In order for checking the accuracy, you are looking at the number R squared value. Yeah, so I'll make this bigger, and here is my R squared value. And yeah, here I can see the number is 0.55. And again, the number I'm comparing with is 0.4 or higher. Yeah, so this should be, I'm looking for, let me leave a line over here. See, I'm looking for 0.4 or, sorry, 0.4 or greater. Yeah, so any number that is 4.4 or greater is what I should be looking at. Or just, yeah, let's use a standard term, that is any number that is greater than 0.04 or 0.4. So here the number is 0.55. So based on this, well, again, there are numerous statistical theories, and if you take one of my class or Professor Ron Miller's class of Business Statistics 1 or 2, that's when you'll be learning, more about these numbers. So for scope of this class, I think this is more than sufficient. So again, you're looking for, like a number that is 0.4 or greater. So the very first thing is I check the significant. Yeah, I have high confidence in the relationship. Now accuracy of the model, any number that is 0.4 or greater. So I have high confidence in the accuracy of the model as well. So now I can move forward. Yeah. So yeah, so this is the first number you check using ANOVA. Next, using regression statistic, I check the adjusted R square, and I got a number of 0.55. I should be looking at 0.4 or greater. So this is definitely high. So I have high confidence in the accuracy of the model as well. Now let's move forward and look at the individual variables, and let's find out which all independent variables, which are among those 5 independents have more impact on the dependent variable, that is your revenue. Now here in the bottom, you will find all the independent variables that are here in our model. The very first item is your intercept. If you remember, this is the beta naught value in like any statistical regression model you have used in the past, or I'll be talking as we go. So just remember, this is your beta naught, or this is your intercept. And then just below that, we have all the variables that we have in our data. Yeah, I'll make this table below bigger. So yeah, these are all local, residential, city type, metro, marketing, sales, investment, estimated population, and average household income. So yeah, these are the four variables that you have look here. And among these, yeah, we should be looking at the p-value. Yeah, so I'll highlight this p-value as well. And similar to the significant F value, p-value tells us how significant relationship between the dependent variable between the dependent and that particular individual independent variable has. Yeah. So again, in this case, this is my independent variable, location, residential, and this is my p-value that tells me how how good a relationship it has with the final outcome, that is your revenue. So in simple statistical theory, smaller the p-value, the more significant relationship is between the dependent and the independent variable. So just like we saw as per the statistical theory, significant F, you're looking for less than or equal to 0.01, and for adjusted R-square you are looking for a value of 0.4 or greater. So in the case of p-value, yeah, I'll copy this whole thing and let me put a number that is 0.05. So as per the statistical theory, statistical rule, you are looking for a p-value. See, I will just say, let's use the standard way, p dash value of less than or equal to 0.05. Yeah, so that's the number you are looking at. I will highlight the whole thing. Maybe this is another separate thing. So let me use a different color. I'll use here also, I'll use a different color. So I'll go from top to bottom and check all the p-values and mark the values which are less than or equal to 0.05 with this orange color I have. So this is 3.3 into multiplied by 1 divided by 10 raised to 8 minus 82. So this is extremely small, almost equivalent to 0. This is also the same, almost equal to 0, 0. So extremely small. Yeah, it's definitely less than 0.05. So I will highlight this with orange color. The next number is definitely greater than 0.05. So I'll leave this alone. Then I'll go to the last one. Yes, it is very less than 0.05. So these are some significant factors, and we'll talk about it shortly. And then I will go ahead, click this orange, because these are the ones that have significant effect. And the one that is greater than 0.05, I will leave it with as is color. So again, you can see that all the variables have a p-value of less than 0.05 except this one. So we will highlight this in a separate color, so we'll leave it alone. Now, once we have identified the key independent variables, we can look at their coefficients. Yeah, so now this is the important number you are looking at. So let's highlight with, say, light green, or I'll keep it the same. Let's use the standard. Yeah, let's keep it orange. Here also I'll keep it orange. Yeah. So yeah, I have highlighted these coefficients, or let me expand this. So this is what we are looking at, coefficient of the ones which are significant, which is 0.05. So indirectly, what this means is now, yeah, once you have done this, so this one coefficient, that is minus 18,843, it means that if the revenue, it means that the revenue of our store is going to decrease by 18,000 units if our store is located in the residential type location. Yeah, so that's what it means. And if not, then you'll be getting a positive number, which is positive 18,000. So that's what it means. Similarly, in the next one, yeah, so in the city type, the coefficient is 4066. That means that if the store is located in a metro location, the revenue from that store will be 4,000 units higher than the other location, that is non-metro location. Now the next important variable to like in case of marketing or sales, is your marketing sales investment. Here the coefficient is 0.4. That means if we increase our investment in sales and marketing by 1 unit, our revenue from that store is going to increase by 0.4 units. Yeah. So that's a significant upward trend, positive trend. Similarly, the average household income. Yeah. So your coefficient is 0.446 units. So you can say that with each increase in household income, there is around 0.44 increase in revenue numbers. Yeah. So that is how we read the results of regression analysis. So first we look, the very first we look at the significant. Yeah. And this is going to be true in any, not only in case of sales data, but any regression model you will be dealing with for your entire life, entire career. This is how you will be reading. Yeah. So the very first number you are looking for is your significant F value in any regression analysis. And it is as simple as that. Yeah. So check your F value. And it should be less than 0.01. Yeah. So again, there are like few different statistical theories. Most of the time it's 0.01. Sometimes they will say 0.05. But yeah, technically it won't be any other than these unless your company you are working for has some specific requirements. Yeah. So statistically, this is the number you're looking for. So in our case, yeah, it's definitely very less than 0.01. So definitely this holds true, so that we can say confidently say that there is a significant relationship between the dependent and independent variables. So once you have identified that there is a significant relationship, then you can look at the accuracy of your model by looking at the R square, yeah, adjusted R squared value. And here you are looking for a number that is greater than or equal to 0.4. So and the number we got is 0.55. So definitely even that criteria is satisfied. So now you can see that our model is our model is going to predict the y variable accurately. Then after looking at these two important variables, we look at those individuals. Yeah. And again, this is always the sequence you should be following, because no matter what numbers you get here, if your significant F is it doesn't match this criteria, or if your adjusted R square doesn't match this criteria, then this won't make sense. So even before going forward with all these detailed analysis, this is the first number to check. Then this is the second number to check. And once that's done, you are ready to go and check the p-values. Yeah. And like most of the statistical theory says that you should be looking at a p-value of less than or equal to 0.05. So here, we go ahead and went ahead and checked and highlighted all the p-values of the respective variables that are 0.05. And once you have highlighted those, we are going to, these are the ones that are going to have impact on your y variables. And here, like any positive increase means increasing that specific independent variable is going to increase your output variable, which is your revenue. And any negative coefficient means increasing any of this is going to decrease. So if there is an inverse proportion, is going to decrease the revenue, that is your output variable. So yeah, this is how you read any regression analysis, which is a very important lesson. And thanks to this Excel data analysis tab that we barely saw a few minutes ago. And doesn't matter how many data points we have. This is exactly how you will be conducting any kind of regression analysis, and this is how you read. So this is one important lesson learned out here. Now let's go ahead and proceed with our next step. Now we have seen our linear regression model. Now let's learn about how to use that result to make a prediction, or in other words, let's see the predictive analysis of the future value based on all the previous data that we have for all the 1,000 stores and all these 5 independent variables and its effect on the dependent variable, that is the revenue. So suppose Mr. John and his team has collected all this data and they are ready for the next set of stores they are wanting to open. And on that note, So they have identified 15 different locations. Yeah. So yeah, these are the 15 different locations and these are the conditions they have. And they want to predict the revenues in in the next 15 shortlisted locations. And they will only make the decision to move forward if the revenues are higher. Yeah. So in other words, so all the data that they have collected, we help them to do the linear regression model to build a linear regression model, understand it, check with go ahead and check if there is any high level of confidence with it. And we over there we checked about, we checked the significant F value, then the adjusted R square value, and then we checked the P values, and based on that we made some predictions. And now parallelly their team has come up with the next, because those are strong sales guys as well as retailer guys, and these are the business people. They have collected this data and they have to make a decision whether or not to move forward with any or all of these 15 shortlisted locations they have. And based on that, they have already collected this data for these 15 locations. And again, it's all the same data that we have seen, type of location, city type, the marketing seal investment they have budgeted for, estimated population in the new 15 new locations, and the annual household income in those 15 locations. And based on that, they want to predict the revenues. And again, they will make the decisions to move forward to start a store, to build a new store or not, if the revenues are higher in these. And if the revenues are not higher, they won't. Or in other words, they'll prioritize the locations that has highest revenue prediction, and then move forward with the remaining. Yeah, so that's how they will be doing. So let's come back to our regression analysis sheet. And yeah, here is where we left last time. And let's get into our new, the last part of this class or this assignment, that is predictive analysis using linear regression model. Yeah. So for that, I will go back to this sheet over here, and this is already provided to you guys. So yeah, check this sheet that says future 15 stores underscore revenue prediction. Yeah, so go here, and here there is a short, I'll say an equation stated, and what are the terminology used. So this is the equation. Your output variable y equals to beta 0 plus beta 1 into x1 plus beta 2 into x2 plus dash 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 beta n into xn. So yeah, suppose there are n number of variable. In our case, we have 1, 2, 3, 4, and 5. So yeah, it will be, we'll be starting with beta 0, then b1, b2, b3, b4, and b5. And our y is our revenue. Yeah. So let's go ahead and add these terms over here. So in my revenue, I'm double clicking and adding my y. So this is my output. And before we get into beta 0, b1, b2, b3, b4, and b5, let's go over here. And I will repeat myself here. So yeah, based on the p values we identified, there is one independent variable or the input variable, that is estimated population in the vicinity, that doesn't satisfy the criteria for the p-value. It is way higher than 0.05. That is set, that is that tells us it is not statistically significant. So we are going to ignore it. Yeah. So again, this intercept. Yeah. So again, here we have this intercept. So that intercept is nothing but here beta 0 or b0. So let me go ahead and write that over here. Yeah, so that we later on when we copy paste, we can refer it. So I'm going to say this is b0, and I'm going to pick po. So here it looks like that, beta 0. I'll just copy this whole thing and paste it over here so that I can have it side by side. And this is how it is. So this is my intercept, my b0 or beta 0. My residential, that location underscore residential is my b1 coefficient. So I'm going to say this is b1, and these are all my coefficient values. Yeah, and this is going to be my b2 coefficient. This is going to be my b3 coefficient. Statistically it's beta 3, and this is the last one, that is b4. And we don't have to go in any level of detail statistically for the scope of this class, because this is all about data analytics. The good thing is that you don't have to understand each and every statistical theory. All you have to understand is this, how to read significant F, then how to read adjusted R square, how to, and after everything, all these criteria are passed or satisfied, then how to read p-value. And if this makes sense, then you use this linear regression model, and this is how you proceed to make the prediction. Yeah. So these are your beta values that we saw. And this is your original equation, linear regression equation. And this is the only equation that you need to know as a part of scope of this class. And even if you go in industry and if you're given a task, if you're given a big data set like this and they say use a linear regression analysis and solve this and make your inferences predictions. This is the exact methodology you'll be using, and doesn't matter if it is sales data, it applies to all type of data. Just remember there should be one output in case of linear, in case of single linear equation, and there should be multiple inputs. Yeah, and again, like all your inputs should be numerical. So if there is any categorical, we convert it into like numerical by the method we used. Now going back here, so we kind of entered all these. So just to simplify our our whole analysis or make our life easier, I'm going to copy this whole part of the table in here, and let's say, let me make this bigger so you guys can view it properly. And maybe I'll paste it over here. Say Control V. Excellent. Yeah, in fact, well, this is hiding, so I'll make it here. So just watch what I'm doing here. Yeah. So my intercept B0. So I'm going to copy this part. Say, let's say I'm going to copy Control C, the very first beta 0 intercept value, that is 54941 point something. And then I'm going to go above this revenue and I'm going to say paste paste values. So that is my beta 0. Same for location residential. Yeah. So I'm going to go here and let me, just to simplify, let me say this is my X1. I'm going to say city metro. This is going to be my X2. Marketing sales investment is going to be my X3. And we are not going to use estimation estimated population vicinity because as per our statistical theory didn't satisfy the p-value criteria, so we are going to ignore it. That tells me it doesn't have any significant effect, or I do not have any confidence based on the p-value, so I cannot use it in my model. Yeah, so with that this becomes my X4. Yeah, so I did that, and here, I mean, in this step, all I did was added this X1, X2, X3, and X4, as well as Y. And now let me make this a little smaller so that I can fit in. This can become smaller. Yeah, I think, everything is fitted in. Perfect. Yeah. So now I copied the very first intercept value above revenue Y. Then I'm going to copy this value, say Control C, and I'm going to paste this above X1. Yeah, I paste value above X1. Next one, I'm going to copy this and paste it above, B2 value above X2. Paste value. Third one is marketing sales investment. That is my B3. I'm going to copy this and paste it above X3, paste as value. And I'm going to ignore this. I'm going to copy this average household income. I'm going to say copy and paste it above household average average household income. That is my X4, and paste it as a value. Yeah. So this is what I did as a part of next step, and all I did is transferred these individual summary coefficient to this individual respective cells to simplify my equation formation. Yeah. So you see, this is just like any mathematical equation. Yeah. Y equals to beta 0, which is intercept, plus B1 into X1. So this is my B1 X1. This is my B2 X2. This is my B3 X3, and this is my B4 X4. Yeah. Even if it sounds confusing, let me do the first, and then you will exactly know how simple it is. So I'm going to start. So very first, say my revenue for this first condition or first estimated sale location or new store location, I'm going to start. So equals to my beta 0, that is my beta 0 plus, and just to make standard practice, I'm going to start with a bracket. So beta 0 plus B1 multiplied by this is my first X1. Oh, sorry, B1 multiplied by is my first X1 and bracket close plus the next one B2 and X2. Yeah. So plus start a bracket B2 multiplied by X2 bracket close plus bracket start B3 multiplied by X3 bracket close plus the last one bracket start B4 multiplied by X4. I'm going to close it out. So this completes my this whole equation. So I'm pressing enter. So this is my predicted revenue based on the linear regression model we created. And now I want to expand it. But again, since I haven't locked in these, if I expand in as is, it is going to mess up my entire equation. So I will go ahead and lock it. Yeah, so I'm selecting this here. And right, I mean, I can add a dollar value. Yeah, I mean, that's the thing I'm trying to do. So I'm adding a dollar. So I'm locking in these cells. So first one is locked. Yeah. Other way to lock, again, this is very simple and I highly recommend you guys do it, is go ahead and select over here so that your equation is seen over here. So I'm going to select this D2, which I want to lock. And now I'm pressing function F4. Yeah, it will add dollar value. That's what I'm wanting. Then I will go to this next E2. I'm going to, on my keyboard, I'm going to hold function and F4. Next one, I'm going to select F2, and now I'm going to hold function and F4. The last one, I'm going to do the same H2 and function and F4, and I'm going to press enter. Yeah. So again, for the first value, it all remained the same. Now I'm going to drag it all the way down to this 15. Yeah. So based on all this 1,000 data points used, and again, all these actual revenue collected for 1,000 stores that are already up and running, and all these independent variables, that is input variables, which has an effect on revenue. We built a regression analysis model. And again, we identified, there is a significant correlation. Again, there is high dependency. I have high confidence based on this. Then I checked the accuracy of the model. It does satisfied. Then I went ahead and checked the p-values and picked the p-values that have a significant, so p-values for the factors that have significant effect on the output, that is your revenue. And I picked those. And based on that, I'm bringing in this linear regression model. And this is your, in statistical world, this is your simplest and this is your standard regression model. So this never changes. Yeah. So yeah, this is how it is. And here, with respect to this equation, just to check the terminal, this B0 is your intercept value, that is 54941. B1 is this your first independent variables coefficient, that is -18843. B2 is for city type metro, that is 4066. B3 is this marketing sales, which is 0.4, and your B4 is 0.446, and we are ignoring or keeping this out because it doesn't satisfy the criteria of p-value. Now, based on this is a very important data collected, and this is as simple as this. Yeah, and this is exactly how you will be running regression analysis in data analytics in statistical world, and and it will be used for making your predictions. Yeah, but in order for you to have confidence in your predicted model, this is the statistical result that you are supposed to be analyzed. And thanks to Excel and this data analysis tab, it is as simple as this, and this is exactly you'll be using throughout your career. Then once you come up with this, you go in your say future, shortlisted locations or different cities where you have collected this input and you want to predict your revenues. Yeah. So now you entered all the numbers and you generated this equation and made this prediction. Now the next step is how do I know, or how do I pick the stores, or how do I prioritize the stores that I should go ahead and start build new stores. So for that, all I'm going to do is I'm going to pick any column in here, and I'm going to go and sort the data. Yeah, sort the data based on revenues. So I'll go to this home tab, and just like we have learned sorting, I'm going to expand this, and I'm going to say sort largest to smallest. Yeah. So based on that, yeah, I can see there are two stores that are giving me revenues of 90,000 and above. And there is one that is giving me revenue almost 85,000, and there are two with 75,000 and so on. So again, this is sorted from largest to highest. So if I was Mr. John, I will definitely prioritize the top three, because yeah, I'm getting higher revenues. And yeah, those are the first thing I'll start prioritize. And as I go, if need arises, I will move forward with opening the stores in the other locations based on these revenue predictions. Yeah. So definitely maybe I will highlight these in green and say these are my top picks. And these are my top picks, and I will start creating or start opening more stores in the respective stores in the in this like top to bottom, decreasing revenue sales. Yeah, so this completes our whole analysis, and this completes our assignment. I hope you guys learned a lot about this interesting topic of regression analysis and predictive analytics, or prediction analysis using regression in Excel. And thank you so much for all your time and attention, and see you all in our next class.